Okay, we're gonna start. So we're doing heat energy today. Hey, give me a wave. How is everybody today? Dinnerbone is upside down. I just wanted to say we're gonna do heat energy today. We're following on from so we're doing. Oh wait, maybe you guys wanna. We'll go this way. I'm back. Okay, I'll put my hat on because it's gonna get hot in here. I'm gonna stop this. All right. So what we're doing today is heat energy. I'll tell you about myself. Hopefully you guys are doing okay with this COVID thing. We'll get the first week out of the way. I've got a crazy bird in my house. Just flew in my house because the back door's open. You can hear that. So today is a good day for me because I have finished my self-isolation for 14 days because I was overseas. And today's my day, and I don't have the virus, which is great. Now I only have to lock down, which is what everybody else is doing. Okay. I'm going to just make sure everybody's muted. Mute all. Okay, there we go. Somebody just blasted in there. Okay, so today, I'll tell you a bit about myself. So I'm Sterling is my first name, Sterling Kathman. I'm from Minnesota. I'm a primary teacher, basically, and I also work at Nayland College doing junior science. We moved over from Minnesota about 20 years ago, and I've got 3 kids, a dog and a cat, and a house in Nelson. So yeah, we're doing well. How are you guys? Are you guys good today? Hopefully you'll be having some fun there with doing your science or doing something at home. Okay, so what we're going to be talking about today is heat energy. I'm just going to give you a little kind of, this is a little outline of what we're going to do today. All right, so we're going to look at glowing and how things glow. Heat energy, because we also talked about how different forms of energy, and heat energy is a good one. Temperature, what temperature is, and looking at thermometers, and a little bit about the COVID, also weather, and then reaction rate, and how temperature affects reaction rate. So when chemical reactions happen, one thing happens because of something else. Okay, so we'll move on from that. That was the whiteboard. So what we're going to be looking at is thermometers. All right. So when we look at, I've got little digitals. Okay. So this is 19.4, which is a little bit easier to read than this. So you guys might be a bit more familiar with something like this. And what we do is we look at there's C and F. You guys may know what C and F are. So that's centigrade and Fahrenheit. So when I grew up, it was all about Fahrenheit. So where water freezes is 0 centigrade. The metric system is way more organized. So they've got freezing at 0 and boiling at 100. And water won't get any hotter. It won't get any hotter at 100 because it just starts boiling and goes into a gas, which we talk when we talking about changing states of matter. And you know what I found out when I was doing, you're going to be looking at glow sticks today. Glow sticks are so fun. I love glow sticks, and we're going to be doing glow stick science. What else are we going to look at? Here's just a little picture of the thermometers. So obviously red or yellow is hot, and blue is cold. Usually that's a fairly universal kind of color scale. So this one, when I was doing a little research on this topic, I found out that the COVID-19, this coronavirus, it doesn't like heat. So obviously it can make you have a temperature, but the heat dries it out. So what they're doing, you can not draw on that place. So you can see the sun actually can really affect this virus. And so it actually, like on a surface somewhere where it's colder, it will stay and it can last for a long time. But when it's warmer, it will actually dries out. So that's different from when it's in your body, but it's just like when it's existing on surfaces, or like if you have it on your hands or something like that. It's like you can use cold will actually what is it? Yeah, cold. It likes the cold and can survive in the cold, but can't survive in the heat. That's it. And here, so we're looking at temperature today. Here's just like temperature in Nelson. So this is where I am. And we're looking at the temperature along the left in centigrade. So like the highest it ever gets. These are just average temperatures, or the maximum temperature in Nelson is 23 degrees in January. And if you look at, you could find this out for wherever you live, but like July, if you look like in the middle, is when the coldest. So there's a lot to do with temperature, all right? You can do a lot of study, you can do a lot of experiments with temperature, and I've got this, we can do glow sticks next, all right? So the glow sticks, I'm just gonna make it a little bit, I'm gonna show you the glow stick and how it works. See if you can figure out, have a look at this, and see if you can figure out exactly how the glow stick works. I'm just making it dark in here so we have some darkness. All right, so did you figure out how it works? Anybody figuring out that? So if you look at it again, so I've got these glow sticks, and inside, so there's this like red stuff. There's a red liquid, and inside, I don't know if you can see it, but there is a glass tube, a very thin glass tube. We'll go back to that other picture. And when you, okay, so that's looking at the top, and then when you crack it, the thing in the middle breaks, as you can see in number 5. Oh, wait, can't see it. Let me do this one again. Oops. Switch. All right. So you can see down at the bottom, in the middle, you crack it, and then in the bottom, it actually combines the two chemicals. I'm gonna do that right now. You can hear it. All right, so what I'm doing, I'm gonna break a couple of these. These are actually different colors. All right, and it's gonna start glowing. We'll give it a second. And then we're gonna see what happens when we put the glow sticks into different temperatures. So I've got ice here. So remember, when we look at ice, it's 0 degrees when we look at temperature, and then boiling is 100. All right, so I'm gonna make a little bit of ice water here. We get ice, and you can practice, and you can say, okay, well, what's ice? How cold is really ice? So once it goes to 0. Once you take it out of the freezer, it immediately, oh, actually, I'll put the, so right now, you can look today, and we're looking at, where are we? In my house, it's 19.3 degrees, all right? And as soon as I put this, so this is, I'll show you this is like a digital thermometer, and I'm gonna stick that end into the ice, and immediately into the ice water, and you should be able to see this go. It takes a couple seconds. All right, so 13.7. You can see it going down right away. Okay, it's gonna take another little minute. And now, okay, it's gone down to 10. All right, so now I'm gonna move that. I'm gonna put hot water in the other one. Okay, we're just gonna try hot water, really hot water. Be careful, hot water is dangerous, so be careful. All right, and then we're gonna have another thermometer and see how hot this is. So I've got putting the end in here. It's just fun to have these digital thermometers. You can use any thermometer at home that you have. So again, we're starting at 19. It's about 19 in my house. And as soon as you put it in the hot water, oh, well, look at that, 44 already. Okay, so it goes, but it's never gonna go hotter than 100. All right, we're gonna do that. Now we'll do a little experiment. So I'm gonna move you guys over to here. All right. All right. So now, I'll bring this back. We've got two cups. I'll do these close together. One's like really hot, and I'm going to put the thermometer in there so we can see how hot. You can watch it go up. So starting at 18.6. All right. So that's up to 66 already. Move this one down. Oh yeah, we'll do the cold one. This is a good little live experiment. All right. And we're gonna stick the this piece of wood under here. Deal with my technology. All right, so this should be better. All right, so that's at 76 so far, and this one is going to go down. Hopefully, well, obviously it will. So that's it. One's at 76 and one's at 19. All right. So now we've got these glow sticks. All right, and I'm going to put the glow stick into the hot water. Ooh, this is a blue one. All right, and you can see. Oh, you can see them starting to glow. All right, so in the hot, they go really, really bright. Okay, and there's another, should be another one there. Let's see what else I can find. Oh, here's a yellow one. Just get that focused for you. So you can see in the when it's hot, it glows. So this is your rate of reaction. So the heat energy actually stimulates the molecules and makes things glow. And I'm going to take, like if I take one, so when you think about when anything, if you add heat to it, it starts going faster. So any kind of, like when you're starting to cook something, right? And so here we're looking at, move this back. So we've got 4 degrees, 2.9 degrees on one side and 67 degrees on the other side. And you can tell, like say when I take this one, this blue one out, I'm going to put this yellow one in the cold, and it'll kind of, the rate of reaction slows down, and you can see right away how it kind of, the light goes out. So that's dead. And then when you put it in here, it starts going again, and it just glows. And so it's actually pretty cool. So it's a really good way to see how the rate of reaction works. All right, just another little experiment that I like to do. So when you've got, I'm going to turn the lights back on for this. So you can see hot water, it glows, cold water, it doesn't glow. And if you add salt to the cold water, so we're going to make ice water. And if we've got ice water, and if you add more ice and salt, it should actually go below freezing. So this is another little trick of science, where you can actually super cool water. This is what happens in the Arctic. And when the salt water is so salty that it actually gets colder, it goes colder than 0, but doesn't freeze. It's got the salt in there. And then chuck in some more salt. Oh no, I just lost. I'll take my filter's thermometer from the hot and put it in the cold. We can watch what happens. I'm going to stir that around, and it should go. You can watch this one move. So we've got that at 28 going down. This is I have 2.6. I'm going to mix it around, and the more salt you put in, the colder it actually gets. I'm going to mix it around a little bit, see if we can get it even colder. 1.5. More salt, more ice. See if we can get it sub-0. And if you mix it, see, it really helps to mix it around. But you can see minus 0.6. Oh, that's not minus yet. Oh, there we go. We got a minus 0.5. See how, so it's still liquid, but it goes colder, and it keeps getting colder because you put the ice and the salt together. It makes a super cold solution. minus. So I mean, that's kind of funny. I thought that. I'll go back over here. I mean, so for me, that is kind of amazing how it goes from just by putting salt in there. You can, here, I'll mix it around some more. You can go colder, because I always thought that, because when you look at 0, in centigrade, 0, which one do we have? Yeah, 0 is always frozen. So you have water, and when you get to 0, it just freezes solid, turns into a solid. But this one, with the salt in it, we've actually got it to minus, oops, it was -2. Now it started warming up. I'll put that back in there. Okay, so this is fun with temperature, fun with rate of reaction. I don't know, look at it's warmed up already. We'll hold on to that one. All right, so I'm just about finished. That's our little science for today. We'll go back to what we talked about. Oh wait, oh yeah, so this is heat energy, temperature, boiling and freezing. You just have to remember that, oh, somebody put their hand up. Raised hands. Dylan, what do you have to say? Wait, I can unmute you guys in a minute. And thermometers, we're looking at COVID. James has got a hand up. We got people doing lots of different things. Okay, I'm gonna show you one more picture before we go. Another thing I was wondering if there's any parents or anything out there. Okay, this is, again, our temperature, what we looked at. So there's centigrade and Fahrenheit, and freezing, if you look on the left, on my left, down at the bottom, it's 0. The blue is 0. And then when you heat it up, it goes up to 100. So boiling is 100, and 0 is freezing. Okay, that's when they change the states. All right, so let me go back to this one. Yeah, did that. Okay, back to me. All right, so I'm going to open this up a little bit, and if you can, I'm going to unmute you guys. Yeah.
Oh, hi.
Hello,
Hi.
Dylan.
I've been listening to music this whole
What's your
time.
YouTube channel?
Pianos.
Oh,
The boy.
Listening to music the whole time. Subscribe to PewDiePie.
Hi, Dylan.
PewDiePie.
Dylan.
To PewDiePie, everybody.
All right. Okay. Well, what happened there? There's somebody's picture. Oh, you guys were skiing. Okay. So I want to just to get a feeling of how you guys are liking this, and you can give me a hint. Is this a good length? Do you want me to go longer? I could go longer every day, or I could go shorter. So if you want shorter, you can do it like this. If you're okay with the length of just like, so every day I'm aiming for like 15 or 20 minutes, but I can go longer if you guys want longer. Or if you're happy, just give me an okay, or if you want more, or if you want less, you can do that. Okay, I'm gonna go, Xander's got it up. Gordon, what do you think? There's James or Violet. Violet wants more. Okay, Gordon wants more. Okay, Daniel and Matthew want more. You guys want longer, so I can go longer. Okay, Dylan and Michaela said this is okay. Some people, there's Noah Wilson and a bunch of people. Naruto says more. I can do more if you want. There's Alexander Card. Okay, thank you. This is good. Good feedback. I'm getting the thumbs up. That's good. So today, hi Lexi, how are you? We have Chris. I'm going to zoom through this. It's just nice to be able to say hello to you guys. Somebody's on the snow. I can see SJ is in the snow. There's A10. Abby. What was Abby's eating a carrot? Abby, I can see you eating a carrot. All right. Beth is there. Hi. Good to see you guys. Okay. I'm going to end with today with this 1 million. What does that one say? 1 million. Okay. Thanks, Josh. Okay. I'm going to go back to me. Here we go to this one. Okay. All right. Thanks, you guys. And have a good day and be safe. Be nice to people. And I'll see you tomorrow. Okay. Bye.